Hello everybody, this video is going over the periodic table trends worksheet that we did in class. It's a great opportunity to go over some of the concepts for chapter 5 and also remember some of the key concepts from chapter 4 as well. So number 1 says, which statement best describes group 2 elements as they are considered in order from top to bottom of the periodic table? So before we answer this question, I want to go over a few things with the periodic table. The first is, remember from our electron configuration chapter that as you go down in periods, you are increasing the number of shells or energy level on your atom. So as you are going from top to bottom on the periodic table, we know that you are increasing the number of energy levels. So we already know that C and D are not correct because it says the number of energy levels remain the same. Then we're going to go look into valence electrons. Now we know that every element in group 1 has 1 valence electron. Every element in group 2 has 2 valence electrons. Every element in group 13 has 3 valence electrons, and so on and so forth. So if we're talking about group 2, we know that every element in group 2 has the same amount of valence electrons. So we know that the answer for number 1 is B. Number 2 says, what is the total number of valence electrons in an atom of boron in the ground state? Now, ground state is just saying a regular boron atom. If it was an excited state, that means that the electron might be moved to a higher energy level. However, ground state is just saying it satisfies the normal rules on the periodic table. So boron is in group 13, and we know group 13 have 3 valence electrons. And that is because they have a full s orbital, which is 2 electrons, and then they have 1 electron in the p sublevel. So that means they have 2 plus 1, which is 3 valence electrons. Then number 3 says, what is the total number of valence electrons in an atom of xenon? Xenon is a noble gas. It's in group 18, so it has 8 valence electrons. Number 4 says the elements calcium and strontium have similar chemical properties because they both have the same, and we were talking about this last chapter, every single element in group 2 have 2 valence electrons, and because they have the same number of valence electrons, that means they're going to react very similarly. So the answer to this question would be number of valence electrons, C. On the periodic table of elements, all the elements within group 16 have the same number of, and again, we were talking about this for the last couple questions, every single element in group 16 has 6 valence electrons. So the answer would be number of valence electrons. So number 6 says an element with a partially filled d sublevel in the ground state is classified as. So let's go over the sublevels on your periodic table real quick. So if you look at our periodic table, groups 1 and 2, as well as helium, are in the S sublevel. Groups 13 through 18 are in the P sublevel. And then we have the D sublevel, which is all of our transition metals. So transition metals would be the answer to this question. And then number 7, which electron configuration represents a transition element? I am aware that they put the D sublevel before the 4s, which is incorrect. However, you should have still been able to figure out that C was the right answer because it is a partially filled D sublevel, which shows that it's ending in the transition metals. So C would be your answer here. All right, number 8 says, which element in period 5 of the periodic table is a transition metal or transition element? So remember, our transition elements are in the D sublevel. If we look at our option choices here, we have strontium, which is in the S sublevel. We have antimony, which is in the P sublevel. We have xenon, which is also in the P sublevel. So our answer would be AG. Number 9 says, which of the following atoms has the largest atomic radius? So we know for atomic radius, the largest atomic radius on the periodic table would be francium. And the trend is that when you go to the left across a period, you're going to increase atomic radius. And as you go down a group, you're also going to increase atomic radius. Now, why going across the period to the right would you decrease atomic radius? Well, that's because, let's say we're talking about period 2. As we are going across period 2 to the right, you are having the exact same number of energy levels, which is 2. But as you are going to the right, you are increasing the number of protons in the nucleus, which is pulling those electrons closer to the nucleus, which is why they are getting smaller in size. Now, if we are going down a group, if we go from hydrogen to lithium to sodium to potassium, as we go down, we're increasing the number of energy levels, which is increasing the size of each coordinating atom. So if we're talking about sodium, potassium, magnesium, and calcium, sodium, potassium, magnesium, and calcium, the largest would be to the left, which is sodium and potassium, and then the most down because it would have the most number of energy levels. So our answer here would be potassium. Number 10 says, which noble gas has the highest first ionization energy? So first ionization energy and electronegativity are going to increase as you go towards the top right of the periodic table. So for ionization energy, it's going to increase as you go right across a period, and it's going to increase as you go up a group. Now, what is ionization energy? Ionization energy is the energy required to remove an electron. So our noble gases that have a full octet, or 2 for helium, it's going to take a lot of energy to remove those electrons because they are so stable. They have all that they want in an atom. So it's going to take a lot of energy to remove those electrons, which means helium is going to be your highest first ionization energy. So since helium is an answer on this question, we know that that is the answer. "12 says, which list of elements from group 2 in the periodic table is arranged in order of increasing atomic radius? So since we are talking about groups, we know that in the atomic radius trend, it is going to increase as you go down a group. So if we have beryllium, magnesium, and calcium, that is going down a group. So that would be increasing atomic radius. So that would be the answer. Just as another example, if we looked at barium, radium, and strontium, that would be barium, then radium, and then back up to strontium. So that would not work for this specific question. Number 13, as each successive element in group 15 of the periodic table is considered in order of increasing atomic mass, increasing atomic number, the atomic radius will blank. So we know as we're going down a group, which is increasing your atomic number, that is going to also increase your atomic radius because you are adding energy levels as you go down that group. Number 14 says the strength of an atom's attraction for electrons in a chemical bond is the atom's blank. This answer is electronegativity. Remember that electronegativity is an atom's ability to attract electrons, which is why our noble gases do not have any electronegativity because they are already stable and have a full outer shell. Now, number 15 says which properties are most common in nonmetals. Remember your nonmetals are over here on the periodic table. This would show high electronegativity and high ionization energy, which means your answer would be D for this slide. Number 16, which group 17 element has the least attraction for electrons? Remember, the attraction for electrons is electronegativity, and the highest electronegativity is fluorine. So if fluorine is your answer choice, that would be the answer. And number 17, which element in group 16 has the greatest tendency to gain electrons? This is basically asking the same thing. The higher up in the group, the more electronegative, which means it's going to have the greatest tendency to gain electrons. So if we have beryllium, sulfur, oxygen, and selenium, oxygen would be the highest in the group and closest to fluorine, which means it has the highest electronegativity or the greatest tendency to gain electrons.